Hi, Joe Cerrone.
And Al Rosen.
Welcome to CAD 117 Intermediate AutoCAD and our weekly Zoom meeting. Module 2. Module 2 has been released. Module 2 works with multi-view drawing, also called orthographic projection. And it's really kind of the basic fundamentals of how we teach drafting with a front, top, and right side view. And we've kind of updated the exercise to kind of bring you into how modeling works, because traditional two-dimensional drawing techniques and being able to model 3D makes it a lot more automated. And so if you're able to model the part, it's easier than it is if you're trying to go through and tag a line in the front view, in the top view, and then project it into the right side view. So we've got these attachments that go along with it. If we take a look at let's take a look at the lecture first. So as we work with multi-view drawing, what we're working with is these different views that are aligned. And we work with these different line types and line weights. And so there's some definitions by American Society of Mechanical Engineers with a drafting standard. And so we'll talk about that. And the book uses a lot of the standards, and that's really what we want. We want you to know where to place the drawing views, what line weights to use, and the line types, so that they're all within this standard. We'll look at third angle projection. That's what we use in the United States. And we'll look at the techniques that we use to create these. And we'll look at these different line types. And so they have this bus, and they use the bus kind of as a way to explain how the layout would work. Here's our front view, our right side view, and our back view. And if you were to line things up with a ruler, you'd be able to draw a line across the top and across the bottom. And then things should line up perfectly. So the windows would all line up, the mirrors would all line up because they have the same height values. And so as we go through and we work with these, the book is broken into architectural and mechanical. So we take it, the bus was the mechanical, and then the house would be the architectural. And it's the same school of thought: front view, right side view, top view. Everything lines up so that somebody can take a straight edge and then be able to project where these different features are. When we start working with mechanical, a lot of what your engineering graphics classes will do is to introduce students to basic drafting representation. And so that's what this is: where to place the views, how to project them. And they use this kind of point system where they project things onto an imaginary plane and a viewer's line of sight. And then it goes through things like, what is true size? Like when you look at something that's 2D, that's projected onto a flat surface, you get this little triangle here, but that's not true size because it's not perpendicular to the point of view. And so there's these things called inclined and oblique surfaces. And this is why modeling solves a lot of these geometric problems for you. If you're able to draw it in 3D, then you can project these automatically. And I think Al's got a system in there called flat shot that he likes to use. And we'll use that in some upcoming exercises with some of our 3D work. And so essentially it just goes through and identifies how to go through and create these different drawings and talks about the different terminology for them. And then it goes through this. This is really quite difficult. If you ever have to work with a pencil, back in the day, I used to have to do this. I used to run the labs up at Northern Illinois University as a grad student. And the first thing we do is put them onto a drafting table and show them how to do this. That was years ago. I put in the CAD labs, and now we're able to actually model the part and then drop off these views. But as you can see, they have this different geometry. And if you just look at the left side view, it's really hard to tell what this looks like without the 3D view. So that's one of the reasons that we're really into the modeling as we go through and we start working with this. So as you start to work with this, what we've done is we've created this multi-view grid sheet. And so if we click on that and then we open that, it's basically just a sheet of graph paper. And we have these different line types that we'll work with. If I want to go and set this up for a visible line, I can set that to a visible line. And then if I come back here to the parts sheet, what we want you to do is to go through and look at the parts sheet and to basically draw these different shapes with the front view orientated to this arrow line of sight. And so you have to count squares: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 by 3. So if I came back over to my drawing, and I were to draw it on the visible line layer, I would start off in this corner and then I would go 10 units over. And if you have the object snap on, that's fine. But if you have the O snap, that may get in the way. So we can turn off O snap and it'll work a little cleaner. And then we can go to 10 units. And maybe my object snap is not on. Let's see. It's not. There it goes. There we go. So we go 10 units, and I believe it's 3 units up. And then we go 3 units over. And then we go 3 units up. And then we go 4 units over. And this is just basically 2D layout work. And so we'd come up with this shape here, hit escape, and then we'd create the right side view of it. And the right side view would be lined up with the front view. And so we would come over 4 units, and then we would come down, over and up. And then we would project this line over here like that. And then we would use a hidden line to project over this line here. And then we would draw the top view in the same fashion. These are very basic types of drawings. As you go through, you want to have an understanding of how drawings were created before there was CAD. A lot of these companies have been around for a long time. I remember when I worked for Dresser Industries, they were the old International Harvester. They had stuff going back many, many years. And so here's the traditional way of drafting. If we look at what a projection line is, that's this line right here. It's called a miter line. What we should be able to do is to bounce a line off a point, and it should line up in the other view. So we bing, bing, like that. And then we can go through and project like this. And so you had to have very good organizational skills to be able to line everything up and to work with it. And so the drawing will look like this when you're done, or at least once you have it started. Use center lines and hidden lines appropriately. And then we're going to model the different parts. And so once you have the 2-dimensional components done, we're going to create 3-dimensional models. And we really like to do the modeling aspect because that seems to be where we're going with these things. And so I could take this part right here if I wanted to, and I can copy it. And then we can put it over here in space. And then what we would do is to grab an isometric view. And there's a couple of different ways that we can work with this. Now, when you work with AutoCAD versus something like SolidWorks, if you extrude it, and if I go through and I switch over to a 3D modeling workspace, and I go to extrude, if you extrude a line, you will get a mesh. And if I turn off the conceptual aspect of it in wireframe, it's going to look like a net. And this is not what we want to do because we can't do Boolean operations on it. It's like an eggshell. And so in order to make it work properly, you have to create a region. And so we can say region. And then we can go and select these lines. And once they're selected, you'll see that the whole thing has a perimeter. And then we can extrude that. So I can extrude this. And I can go 4 units up. I can go back to conceptual. I like to orientate the parts in the way that they look on the sheet. So if we come back here to this sheet, I like to 3D rotate them into place. And so I'll come in and I'll go and I'll grab the gizmo for 3D rotation. I'll select it and then I'll grab the axes. And I didn't really grab it in the right spot, so it's kind of wonky there, but that's okay. I've done it enough that I can make it work. And so that's how that would look. And then what I typically do is I'll go into the layout mode and then I'll put the view from the front. I would say the top view here. And I would go and put that into a page. And I prefer title blocks, but we'll accept it like this. Want that to be a little bit bigger. You know, try to fill up the page with it. And then on the next layout tab, what I typically would do would be to do the other geometry. And so you want to keep it far enough away from the two-dimensional stuff. And you have an infinite drawing board. So don't feel like everything's got to be on top of each other. You can space it out as much as you want. And so I could go and I could set this up, move these so that they look like my picture. And there's a lot of work out there for people who like this kind of thing in magazines and online development. We've had a number of people get hired by McMaster Carr because everything is now very CAD based. You can actually go into their catalog and download CAD files that you can use in your design work. And so it's kind of nice because you don't have to be an engineer necessarily to get a job using CAD nowadays. And so I would set these up kind of in a similar fashion to this. I don't really need this 2D geometry anymore, so I'm going to let that go. And that's basically lab 2. You'll complete these different 2D and 3D models based on these orthographic projection techniques. With that, Al, I'm going to ask you if there's anything else that we need to cover in our Zoom review.
Hey, Joe, could they use another way to, instead of extrude, another program or another software to bring it up a little larger?
I think this is good for the second week. You know, I think we'll see how everybody does with it. I think the way we want to start them with is just with extrude and revolve type commands.
Okay. How about like press pull command?
Yeah, definitely. We could do press pull, you know, so if we went back to our drawing and we went back to our 2-dimensional, and then I have a second 2-dimensional one here, I believe. And I think it's in model space here. So for example, if I wanted to press pull this circular shape, you want to copy it, which is a little different than some of the other programs, the other parametric ones. So there's some redundancy in AutoCAD. And so we bring this over here. And then when you press pull something, you have to make I'll show you what I mean. So if you press pull it and you hover within an area, it will stop when it meets another feature. So it will stop at the center line. So when you work with these press pull commands, and I remember when it first came out, some of the instructors said it was so easy to use, and it is. It works terrific. Press pull, you hover within the boundary, and then you just pull it up to the size that it should be. I'm just going to guess that it's 7. It's probably 6. If it's not, you can click on it, and then you can adjust it with a grip and bring it down like that. And these are terrific because we can 3D print them. We can do a number of other things with it. All right, Al, anything else?
I don't think so. I think that's about it. Making sure you put it into the assignment box and folder and making sure we can get graded on it, please. You should be able to grade, we should be able to grade your first module and the second assignment also, hopefully before the end of the next week.
Sounds good. So with that, I'm going to end this Zoom recording and then we're going to open things up for questions.